Hello everyone, we are proud to present the topic Detections of Face Marks Overall the Problems amidst the COVID-19 crisis. Wearing face masks has become a way of protection from the virus. Wearing a mask is another way to help prevent the spread of the virus. But there are some who do not strictly adhere to preventive measures until the outbreak of the virus continues. Wearing a mask to public place is a must, so our group through of doing a project on the topic of wearing mask detections to check people before entering various places in order to reduce the spread of the virus.
For overall of method, we use MTCNN for face detection and use Inception V3 for mass detection. The result have mass and no mass. MTCNN model or multitask cascaded convolutional neural network is a neural network which detects face and facial landmark on image. It was published in 2016 by Sang et al. It has three types of MTCNN: have PNet, RNet, and ONet. And we use transfer learning. It's a research problem in machine learning that focuses on storing knowledge gained while solving one problem and applying it to a different but related problem. For example, knowledge gained while learning to recognize cars could apply when trying to recognize trucks. And we use Inception V3. It's a neural network architecture for image classification. And dataset, we collect images of people wearing masks and not wearing masks in many actions. The picture in slide is example of datasets. For evaluate datasets, the dataset will created and evaluated by ourselves. So this dataset will suitable with our project. Because any bad data, we don't use it.
The list of paper or websites as reference. The first is joint face detections and alignment using multitask cascaded convolutional networks. Next is detections of face masks using convolutional neural networks. Next is face mask detections, Classifier, and model pooling with Keras Surgeon. The last one is face mask detection using deep learning and approach to reduce risk of coronavirus spread. Our group have 5 members. The first, Ronnakorn Sanyee, 6230 613003, 5 paper or website that plan to read as reference and make a presentation. Next, Thaswan Rakwit, 6230613011. Correct the datasets and make a presentation. Next is Teerawut Saesim, 6230613020. Coding and evaluate dataset. Next is Amarin Kongthong, 6230613021. Coding and evaluate datasets. The last one is Nattapong Bunchokying, 62T0613032. Correct the datasets and make video presentations. Other parts of work together. Demo of projects and how it works. Detections of face mask.
Hello, for the course part, I will explain the importance of it. Okay, so the first important of it is the MTZN, that the outsourced library that we downloaded from the outsourced okay. And when we want to know that, we for the this project for the MTCN it work or not, so we have to test it by using that. For the first of all, select some image by using the CV2 and design of it, and using the convert color for convert it to RGB color, and print it for check to show the first, and using the function of MTCNN and declare something for get the detector detect face by using that image that we selected, and cop it by using the for loop for finding the first part for finding the position of face, and crop only the face, okay. And next part for the size of it, we have to use the CV2 for the size again, and using the matplotlib to print, okay. So when we show that the function it works and can show the face, okay. And so we know that it can work, so we will use it by using it in the for loop for cop every image on the directory by cop in each picture, okay. So when cop it and get it, so we will return the numpy array on the face and target. For the face, for get the each image information, okay. And for the target, for get the each image target that were matched or not to the 0 or 1 light, okay. For in this part, for set the image mask and target mask, for set the path of it to the 0 that is the where mask, and about the image no mask and target no mask, for set the direction for the one that the didn't wear the mask. For the X, we concat the image mask and image no mask together for set to be the data of X, and the Y use the numpy concat for target mask data and target no mask data together and to be the Y, okay. And about this part for physical of X, by divide the 255 for set the range of it to the 0 and 1. And this part for using the 10 test bit for import the it from the SQL module section for set the test size to 10% and 10 size to 90% for 10 tests of it, okay. And set the random state to the
After I finish to the speed the data, the next I will have to use the data augmentation for the balance the data and increase the data size. I will have to use this function image data generators, and I will have set about the parameter of rotation length, high shift range, width shift range, and validation speed, and fix the image data generators. And the next step in the setup model, I will have to use P10 model to the inception v3, and I will have to set up the weight to use the image datasets, and set up the input shape to the 224 multiplied by 224 multiplied by 3 is same to the crop image, and you can see in the above. And the next I will have to set up the layer of inception v3 trainable to the fault. And the next I will have to use the fine tuning method to the add the models, and I will have to use fastest layer, dense layer, and all of this I will have to use activation function to the lead loop.
And the last layer I will have to use sigmoid and output it have a 1 because output of the mass detection is have two output is have a mass on where mass or not so where mass is enough for the use the sigmoid activation function. And the next I will have to combine the model by the Keras model. And the next I will have to set up the optimizer, and I will choose the STD and set up the import to the 100 and the L to the 0.01. And the next I will have in the model compile I will have set the loss to the binary cost entropies and set up the optimizer to the SGD and metric to the accuracy. And the next I will have to fit the model to use the data generated to the generate the training set and the validation set, and set the import is the same of this. And the callback I will have to use early stopping and set the min delta and the patient to the 3. Okay. And when finish of fit of this model I will have to use the evaluation method to the evaluate the model, and I will have to use confusion metric and accuracy score. And the first step I will have to predict the X test, and I will got the Y predict, and I use the Y predict to the change the around and change the in data type to the in. And the last one I will have to pin the accuracy and pin the heat map of the confusion metric to the Seaborn libraries. Okay. And accuracy score I will got 97%, and confusion metric I will have a wrong is have a 1.
Further applied. Apply in restaurants, shopping malls, or different public places by attaching this model to a CCTV camera to capture images of people wearing masks or not wearing a mask that enter that place for the governments or organizations to analyze the percentage of those who cooperate and those who do not cooperate with the current measures to increase or decrease measures to prevent the spread of the virus in the future. Wearing a community face mask can prevent the spread of virus because you and other one can be a carrier. It keeps you out of trouble too, because wearing a face mask is now mandatory. Thank you.